Eric Burgess here, and we've been asked to find the area enclosed by two parabolas, y equals x squared and y equals 2x minus x squared. So looking at these, there's a couple ways we could go about it. Let's start out with just a sketch. A sketch is usually, I think, the most straightforward way to do it. So I'm just going to go ahead and create an axis here. We're going to have y and x. And let's go out to +3 and -3. And since we have an x squared, that's a standard one. So that one should be pretty easy. We'd wind up at 1, and then it mirrors itself, and then at 4. And then the 3 would go up to 9. I'm not even going to bother with 3. So our first curve, and of course at 0, we are at 0. So our first curve is going to look something like this. Like so. And then it goes up and up and up in the parabolic fashion. All right, so our next curve, 2x minus x squared. So what's interesting about this is, right, the first one's just x squared. So this one's going to be 2x minus whatever x squared is. So x squared is going to get bigger and bigger and bigger. And x squared is going to get bigger faster than 2x can get big. So you could sort of look at this and realize that the only place that these two curves will really intersect will be at very small values, which is why I'm not really bothering to go out that far. But if you don't see that, if you don't notice this, or maybe that sounds a little confusing, you could always just plug in points and begin to plot, and the pattern will become very clear in this case quite quickly. So let's say that we're going to do 0 first, right? I'll do this one in red. So we've got 0 for 0 would be the output. If we put in +1, we're going to get 2 minus 1, which is 1. So they share the same point right here. And if we plug in -1, we're going to get -2 minus 1. So that's -3. So at -1, we're going to get -3. Now if we plug in +2, we're going to get 2 times 2, that's 4. By the way, I'm plugging them in here if you're confused where I'm plugging them in. So 2 times 2, that's 4. Minus 2 squared is also 4. So this is going to give us 0. So at 2, we're back to 0. And this is the parabolic shape's going to dominate. So we'll actually see it become more and more parabolic despite it being shifted by this function. And then we're going to have, for -2, we're going to have -4 minus 4, that's -8. So, right, we're already going to be way down, one up, way down here. And if we were to go one more and go 3, I'm not even going to bother with -3. It's going to be really big. That's going to be 2 times 3, that's 6, minus 3 squared, that's 9. We're going to get out -3. And so here we see we actually match up with the other side. And this is the shape that we would have. Something like this. And from this, we see a questionable area. The only area that they really appear to have anything that could cross is right here. Now, sketching it, I drew the red on top and the black on bottom. I could have drawn it wrong. It could actually be the other way. It's just a sketch. So we have to go in and just verify which one's bigger, right? Because if we're going to take an integral of the area between them, which I guess I'll shade in here as green, this area here, we need to know which curve is really actually on top and on bottom. So all we got to do is pick a point in there. I'm going to pick 0.5, half. Easy to evaluate. So for y equals x squared, if we put 0.5 and we square it, 0.25. Now, if we do the same thing over here, we're going to get, for the other curve, y is equal to 2 times 0.5 minus x squared, 0.5 squared, which you already have, but I'll write it out here anyways. Good to show work, right? We're going to get 1 here, minus 0.25. So we are going to wind up with 0.75. So we see that this curve's actually on top in this little segment here. So happened to sketch it correctly, but you definitely want to check. So that means that we're going to take this curve and subtract it from this curve to find the area that's right here. because this curve's the one that is on top. So our integral, and it's a definite integral, we're going from 0 to 1 because that's the only spot that these curves cross each other. And we're going to have first the curve that's on top, which is the one we sketched in red, which is 2x minus x squared. We're going to subtract from it the function that's on bottom, which is just x squared. And then we're going to take dx. All right, so looking at this, let's go ahead and simplify it. We're going to get 0 to 1, 2x, and then we can combine the x squareds to make negative 2x squared dx. And from here, we can integrate. The x will integrate to x squared over 2, which will simplify with the 2. But I'm going to go ahead and write it all out so it's extra clear. So this is this 2. And then we're going to have x, it gets plus 1 and divided by what we added. So that when we take a derivative, they cancel and we're left with this. Minus, and we're going to get the same thing with this one. We're going to add 1. So we're going to get x cubed and we divide by that 3. And then we keep the 2. And of course, each one of these is evaluated from 0 to 1, from 0 to 1. Now from here, we can go ahead and simplify. And let's go ahead and plug in the zeros. We're going to get x squared from 0 to 1 minus, we're going to get 2/3 x cubed from 0 to 1. So 0 to 1, 1 minus 1x squared is just 1. Minus 0 squared is 0. So this is just going to become 1. Minus, we're going to do 2/3 times. And then again, x cubed raised 1x cubed is going to be 1. And 0 cubed is going to be 0. So we're going to get minus 0, which would just be 1. So we get 1 minus 2/3. And if we do this, we're going to get 1/3. And now, when you do this, you could just stop here. However, some instructors place emphasis on the units. They want you to show that because this is an area, they want you to show that you know that it's square units. It's not just a pure number. It represents an area under a curve. And this just shows that you understand that this is an area. And when they don't give you the units, we kind of just make up this fictitious units just to sort of draw attention to the point. Because when you do applications with integrals, which you will do a lot of, it's important to understand sort of the difference there. And that's how you do this problem. If you have any questions about this, feel free to drop a comment down below, subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.